In indefinite integral, last topic which we are going to cover, that is integration by partial fractions. Now, before partial fraction, you should know the concept of rational function. The function which can be written in the form of fx upon gx, where fx and gx are polynomial, is known as a rational function. Now, meaning of binomial, I hope all of you know. Binomial means an algebraic expression in which the power of variables in each and every term whole number is known as polynomials. Now, a function which can be written in the form of fx upon gx, where fx and gx are binomial, known as rational function. Now, if fx upon gx written, there are two situations arise. Is difference of degrees of fx and gx. If degree of fx is less than degree of gx, degree of fx means highest power of variable in function fx. If highest power of variable in fx is less than highest power of variable in gx, that is we can say degree of fx is less than degree of gx, then it is known as proper rational function. For example, x square upon x minus 1 into x minus 2 into x minus 3. Here, degree of numerator is 2, and in denominator, if you open the bracket, then highest power of x is 3. Hence, we can say degree of numerator is less than degree of denominator, means it is the example of proper rational function. Second example, x square minus 1 upon x square, x cube minus 1. Here, highest power of variable in numerator is less than highest power of variable in denominator. Therefore, it is also a proper rational function. One more example, 2x plus 1 upon x square minus 5x plus 6. Again, it is written fx upon gx part. Fx is a polynomial, gx is polynomial, and degree of fx or degree of 2x plus 1, which is 1, is less than degree of gx or degree of x square plus 5x plus 6. Now, partial fraction. Every partial rational function can be expressed as the sum of number of partial fractions. For example, if proper rational function is given as x square upon x minus 1 into x minus 2 into x minus 3, then we can say same fx upon gx we can write in the form of 1 upon 2 upon x minus 1 plus minus 4 upon x minus 2 plus 9 upon 2 whole upon x minus 3. Base denominator, there are 3 factors. We are writing 3 factors as separate terms. In separate terms, you are using these 3 factors. Then we find the value of numerator, and if you are able to write denominator as in separate terms, it is known as partial fractions. Now, different types of rational function and types of partial fraction we are going to discuss here. If fx upon x minus a into x minus b. This example I am taking for proper rational function, means degree of fx should be less than degree of denominator. Then we can write partial fraction as a upon x minus a plus b upon x minus b. And after that, by equating these two, you have to find the values of a and b. Here, if proper rational function is given in the form of fx upon, in denominator 3 factors are there, then we can write upon as a partial fraction a upon x minus a plus b upon x minus b plus c upon x minus c. If the function fx upon x minus a whole square given, then as a partial fraction we want to write, we can write it as a upon x minus a plus b upon x minus a whole square. Fourth case, if fx upon x minus a whole square into x minus b given, we can write this as a upon x minus a plus b upon x minus a whole square plus c upon x minus c. Or in third case, if we write fx upon x minus a whole cube, then a upon x minus a plus b upon x minus a whole square and plus c upon x minus a whole cube. In that pattern, we can write it as a partial fraction. Or in fifth case, fx upon x minus a into second factor x square plus bx plus c given, which we cannot factorize further. Then as a partial fraction we can write as a upon x minus a plus, since here denominator factor is quadratic, therefore in numerator we will write as a linear, means bx plus c. In denominator both factors are quadratic binomial and further not factorization, or if we cannot factorize them further, then we can write ax plus b upon x square plus x plus b plus cx plus d upon x square plus x plus d. To follow this rule, we can find the values of a, b or c, and after that we can write any function as a partial fraction. Objective of partial fraction to integrate the questions or any question easily. For example, if degree of fx is equal to degree of gx, or degree of fx is greater than degree of gx. First case we have discussed, when degree of fx or degree of numerator is less than degree of denominator. Here degree of numerator is equal to or greater than degree of denominator. Then first we divide fx by gx, find out quotient and remainder, and after that we can write in the form of proper rational function. Fx upon gx written, first you divide, find out quotient plus remainder upon gx. For example, and here remainder upon gx is a proper rational function which can be integrated easily. Now, one example, let rational function is x cube upon x plus 1. Here you can observe degree of numerator is 3 and degree of denominator 1. Since degree of numerator is greater than degree of denominator, therefore write down fx at x cube and gx x plus 1 and then divide x cube by x plus 1. And when you divide, the remainder will be minus 1 and quotient x square minus x plus 1. You can divide yourself and division over, then we can write fx upon gx equal to quotient plus remainder upon gx. Is x cube upon x plus 1 equal to, now division, quotient and remainder, just by division, I want to verify it. We have to divide x cube by x plus 1. First step, how many times? X square. If you multiply x by x square in x plus 1, we will get x cube plus x square times, and here you will get x cube plus x square. Now subtract, x cube cancel out, and here minus x square. Now how many times? Here x written, minus x square required, therefore multiply by minus x, and you will get minus x times. If you multiply, the result will be minus x square minus x. Again subtract, minus x square plus x square cancel out, remainder is x. Now next, here x written and fx x plus 1 given. How many times? 1 time. Then x step plus 1 multiply by plus 1, we will get here x plus 1. Again subtract, x cancel out, and remainder is minus 1. Therefore x cube upon x plus 1 we can write as quotient, that is x square minus x plus 1, plus remainder minus 1 upon x plus 1. And after that, second term easily we can integrate. If same question, we have to integrate x cube upon x plus 1. This step first divide numerator by denominator, and you will get, as discussed earlier, x square minus x plus 1 plus minus 1 upon x plus 1. Write separately x square minus x plus 1 dx plus minus 1 upon x plus 1. Integration of x square is x cube upon 3 minus integration of x is x square upon 3 plus integration of 1 x minus 1 upon x plus 1. If we assume x plus 1 as t, dx equal to dt, and integration of 1 upon t is log t. Therefore, integration of 1 upon x plus 1 is log x plus 1, or plus a constant of integration c. Therefore, if degree of numerator is greater than degree of denominator, then first we divide and write the question in the form of quotient plus remainder upon gx. After that, integrate separately and you will get result. Now, second situation, integration of proper rational function. First case, integration of x upon x plus 1 x plus 2. Already in table we have discussed, if any question given fx upon x plus a into x plus b or x minus a into x minus b, then we can write this as, for partial fraction, a upon x plus 1 plus b upon x plus 2. Or separately we can write integration of a upon x plus 1 plus b upon x plus 2 dx. Now your main objective, in place of x upon x plus 1 into x plus 2, we are writing a upon x plus 1 plus b upon x plus 2. Now we have to find the value of a and b such that LHS equal to RHS. Means x upon x plus 1 into x plus 2 equal to a upon x plus 1 plus b upon x plus 2. In RHS, take LCM. The next step, denominator cancel out, x equal to a into x plus 2 plus b into x plus 1. One method given in your NCERT book, textbook. In that book it is given that now open the bracket and equate coefficients of x and constant in both sides. You will get two equations in terms of AB, and after that solve both equations and find the value of A and B. Now second method, which is given in Vedic mathematics. Using Vedic mathematics method, if equation second you are getting, if it is an equation, it implies we can put any value of x. Equation will always balance. Any value of x, we should select such value of x for which we can find the value of a and b. If we put x equal to minus 1, then second term will be 0, and directly we can find the value of a. Or if we put x equal to minus 2, then first term cancel out, and directly we can find the value of a. It is more easy method which is given in Vedic mathematics to find the value of a and b for partial fraction. If we put x equal to minus 1, LHS minus 1 equal to a into minus 1 plus 2 plus b into minus 1 plus 1, which implies a equal to minus 1. If we put x equal to minus 2, directly we can find the value of b, which is equal to 2. So this method is given in Vedic mathematics, and which is more easy for the students to find for solving the questions based on partial fraction. Now, in place of a, we write minus 1, and in place of b, 2, and simplify RHS. After solving, you will observe LHS equal to RHS. Therefore, in the question I, as given here, in place of a, write down minus 1, and in place of b, 2. I equal to, you will get minus 1 upon x plus 1 dx plus integration of 2 upon x plus 2 dx. I equal to integration of x upon x plus 1 into x plus 2 dx. By putting value of a and b, minus 1 upon x plus 1 dx plus 2 upon x plus 2 dx. The next step, minus 1 outside, 1 upon x plus 1 plus 2 upon x plus 2 dx. In place of x plus 1, if we write t, dx equal to dt. It implies 1 upon t dt you are getting, and 1 upon t dt means log t. Therefore, integration of 1 upon x plus 1 dx equal to log x plus 1. Similarly, 2 you can write outside, and 1 upon x plus 2 to integrate. Again you will get the result as log x plus 2 dx. Therefore, next step, minus log x plus 1 plus 2 log x plus 2 plus constant c. Then using formula of log m power n equal to n log m. It implies n log m we can write as log m power n means log x plus 2 whole square. Then next step, rearrange, write positive sign, log with first is negative second step. Then apply formula log m minus log n, and which is equal to log m upon n plus a constant c. In this final result we are getting as integration of x plus 1 into x plus 2 x upon equal to log x plus 2 whole square upon x plus 1 plus a constant c. It is the first case where two factors given as a linear factor. Now, in next example, there are three factors. Again, it is a proper rational function because degree of numerator is less than degree of denominator. Then 3x minus 1 upon x minus 1 into x minus 2 into x minus 3. We can write as here, it is the sign of integration equal to integration of a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3 dx equal to write separately, and you are getting equation first. Then let 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 as a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. Take LCM in RHS. And numerator you will get a upon x minus 1. LCM is x minus 1 into x minus 2 into x minus 3. You are getting this result. Or one more option, you can transfer denominator in RHS. If you multiply both sides by x minus 1, x minus 2, x minus 3, then directly you can write this result. 3x minus 1 equal to a into x minus 1 cancel out. What remains? X minus 2 into x minus 3 plus b x minus 2 cancel out, x minus 1 into x minus 3 plus c x minus 1 into x minus 2. Again, use the concept of basic mathematics, because if you open the bracket, equate coefficients, you will get three equations in terms of ABC, and which is very difficult to solve. Therefore, in basic mathematics, we can put any value of x. Now, if you decide the value of x for which easily we can solve it. If we put x equal to 1, then what happens? Coefficient of b becomes 0, means this term will be 0. Coefficient of c again 0. It implies the result which you will get 3 into 1 minus 1 means 2 equal to a into 1 minus 2 into 1 minus 3. 1 minus 2 into 1 minus 3, which implies 2 equal to a into minus 1 into minus 2. Therefore, 2 equal to 2a or a equal to 1. Similarly, put x equal to 2. If we put x equal to 2, first term 0, third term 0. Only one term remains in RHS, that is terms of b. LHS you will get 3 into 2 minus 1, so 6 minus 1 5, equal to b into 2 minus 1 into 2 minus 3, which implies 5 equal to minus b or b equal to minus 5. If we put x equal to 3 in second, we get LHS as 3 3 are 9 minus 1 8 equal to c into 3 minus 1 into 3 minus 2, which implies c equal to 4. In this pattern, we can find the values of a, b and c. Then put the value of a, b, c in equation first. The result you will get is I equal to integration of 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 dx equal to a upon x minus 1. A means value of a is 1 to 1 upon x minus 1. B upon x minus 2, value of b is minus 5 upon x minus 2. Plus c upon x minus 3 means 4 upon x minus 3. Integration of x minus 1 is log x minus 1. Minus 5, integration of 1 upon x minus 2 means log x minus 2. Plus 4 log x minus 3. Hence you are getting final result as integration of 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 dx equal to log x minus 1 minus 5 log x minus 2 plus 4 log x minus 3 plus c. The first example we have discussed, when degree of numerator is greater than degree of denominator. Second example, in denominator 2 linear factors. Next example, in denominator 3 linear factors. Now in example 4, in denominator 1 linear factor and second is whole square form. Means x minus a whole square into x minus b in that form. In partial fraction table, remember the assumption part we can write as a upon x minus 1 plus b upon x minus 1 whole square plus c upon x plus 2. Write separately. Now to find the value of a, b and c, equate, let x upon x minus 1 whole square into x plus 2 equal to a upon x minus 1 plus b upon x minus 1 whole square plus c upon x minus 1. Again same process. One method, take LCM here in denominator. Otherwise second option, multiply by denominator of LHS in both sides. Multiply by denominator of LHS in both sides. What remains in LHS? Only x you will get, and in RHS a into x minus 1 cancel out, remaining part is x minus 1 into x plus 2 plus b x minus whole square cancel out, x plus 2 remains, plus c into x plus 2 cancel out, x minus 1 whole square. Now again put x equal to 1. If we put x equal to 1, the first term 0 and third term 0 only. Second term remains, means we can find the value of b easily, and value of b equal to 1 by 3. Next step, if we put x equal to minus 2, then first term 0, second term 0, and we can find the value of c. In place of x, write down minus 2. Then value of c equal to minus 2 upon 9. Now third case, x equal to 1, x equal to minus 2, already we have substituted. Now here you can observe the third situation is not possible directly to find the value of a, so that any value of x we can take here. But before taking the value of x, keep in your mind you have to take easy value of x so that solution become more easy. If we taking x equal to 0, then it is very easy. In place of x, write down 0. So let's say 0 equal to a into minus 1 into 2 plus 2b plus c. Already value of b and c calculated here. Value of 2b is 2 into 1 by 3 plus c means minus 2 upon 9, and therefore it is first time is 2a. Minus 2a transfer left side means 2a. 2a equal to 2 upon 3 minus 2 upon 9 equal to 4 upon 9 minus 2 upon 9, which is equal to 2 upon 9. Put the values of A, B and C in equation first. We will get the result as I equal to integration of x upon x minus 1 whole square into x plus 2 equal to a upon x minus 1. Value of a is 2 upon 9. Therefore, integration of 2 upon 9 upon x minus 1 dx plus b upon x minus 1 whole square. Value of b is 1 upon 3. 1 upon 3 x minus 1 whole square dx plus value of c is minus 2 upon 9 minus 2 upon 9 x plus 2. 2 upon 9 right outside 1 upon x minus 1 integration plus 1 upon 3 and 1 upon x minus 1 whole square means x minus 1 power minus 2 dx minus 2 upon 9 1 upon x plus 2 dx. 2 upon 9 integration of 1 upon x minus 1 is log x minus 1 plus 1 upon 3 x minus 1 power minus 2 apply the formula of x power n. Integration of x power n is x power n plus 1 upon n plus 1 x minus 1 power minus 2 plus 1 upon minus 2 plus 1 minus 2 upon 9 log x plus 2 plus a constant c. Next step 2 upon 9 in first and third term take common, then apply formula log m minus log n log m upon n minus 1 upon 3 because minus 2 plus 1 means minus 1 and minus plus multiply minus 1 upon 3 as it is and x minus 1 power minus 1 which we can write as 1 upon x minus 1 plus constant c. Therefore, final result integration of x upon x minus 1 whole square into x plus 2 dx equal to 2 upon 9 log x minus 1 upon x plus 2 minus 1 upon 3 into 1 upon x minus 1 plus constant c. Now, question number 5. Next situation. One in denominator, one is a linear factor and second is quadratic. If denominator factor is a linear factor, then denominator you will numerator write as a, and if denominator it is a quadratic, then numerator write as linear means bx plus c. For partial fraction 2 upon 1 minus x into 1 plus x square we can write as a upon 1 minus x plus bx plus c upon 1 plus x whole square 1 plus x square. Write separately and form as equation first. Therefore, 2 upon 1 minus x into 1 plus x square we can write as a upon 1 minus x plus bx plus c upon 1 plus x square. RHS taking LCM 1 minus x into 1 plus x square LCM 1 minus x cancel out to a into 1 plus x square plus bx plus c into 1 minus x. Denominator cancel out and you are getting equation second. Now put, if we put x equal to 1, this second whole term becomes 0 and we can find the value of a. Therefore, put x equal to 1, we will get 2 equal to a into 1 plus 1 square, 1 square means 1. 2 equal to 2a or a equal to 1. Now next, if we put x equal to 0, the result we will get 2 equal to, in place of x 0, a into 1 is a plus b into 0, 0 plus c into 1 minus 0 is 1. 2 equal to a plus c. Since value of a is already calculated as 1, therefore c equal to 2 minus a equal to 2 minus 1 equal to 1. In this pattern, value of c equal to 1. Now, any other value of x you put and find the value of b. If we put x equal to minus 1, then LHS 2 equal to 2a plus, in place of x minus 1 minus b plus c into 2. Put the value of a and c. Then 2 equal to 2 into 1, 2 minus 2b plus 2c. 2c means 2 into 1, 2. Therefore, 2b equal to 2 or b equal to 1. Now put the value of A, B and C in equation first, we will get the result as integration of 2 upon 1 minus x into 1 plus x whole square equal to a upon 1 minus x. Value of a is 1 to 1 upon 1 minus x plus bx plus c. Value of b is 1 and c 1 means x plus 1 upon 1 plus x square, which is equal to 1 upon 1 minus x integration first step, and write separately you will get x upon 1 plus x square plus third term is integration of 1 upon 1 plus x square. First term integration of 1 upon 1 minus x dx plus 1 upon 2 into 2x. Multiply numerator and denominator by 2 so that numerator becomes a differentiation of denominator, because 1 plus x square, if you differentiate numerator you will get 2x. So that next step 1 upon 1 minus x, just oral calculation, if we let 1 minus x as t, then minus dx equal to dt or dx equal to minus dt. So therefore you will get minus 1 upon t dt, and minus 1 upon t dt means minus log t, and log t means log x minus 1 plus 1 upon 2. If we let 1 plus x square as t, then differentiate. So 2x dx equal to dt. So 2x dx equal to dt means 1 upon t dt, and 1 upon t dt means log t, log 1 plus x square plus 1 upon 1 plus x square direct formula, that is equal to tan inverse x. And in this pattern you are getting final result as integration of 2 upon 1 minus x into 1 plus x square equal to minus log x minus 1 plus 1 upon 2 log 1 plus x square plus tan inverse x plus a constant c. Now next and last example, here direct partial fraction not possible. Integration of 1 upon x into x power n plus 1. In this question, first we have to substitute, after that partial fraction. For substitution purpose, multiply numerator and denominator by x minus 1. Numerator x minus 1, denominator x minus 1 into x means x power n. Then next step, let t equal to x power n. So dt by dx equal to n x power n minus 1, or 1 upon n dt equal to x power n minus 1 dx. In place of x power n minus 1 dx, write down 1 upon n dt. We will get I equal to 1 upon n integration of 1 upon t into t plus 1, and now partial fraction you can write 1 upon n, 1 upon t into t plus 1 we can write as a upon t plus b upon t plus 1, means 1 upon t into t plus 1 equal to a upon t plus b upon t plus 1. Apply the same process by taking LCM, denominator cancel out. Then first put t equal to minus 1, we can find the value of b as minus 1, and if we put t equal to 0, then value of a will be 1. Now put the value of a and b in equation first, and we will get the result as I equal to x power n minus 1 upon x power n into x power n plus 1 equal to 1 upon n integration of 1 upon t into t plus 1, which is equal to 1 upon n a upon t plus 1 upon n integration of b upon t plus 1. Value of a is 1 and b equal to minus 1. Put and integrate it. 1 upon n log t minus 1 upon n log t plus 1. Now in place of t, write down x power n, and result you will get 1 upon n log x power n upon x power n plus 1 plus constant c. Hence final result, integration of x power n minus 1 upon x power n into x power n plus 1, or which also we can write as integration of 1 upon x into x power n plus 1 equal to 1 upon n log x power n upon x power n plus 1 plus a constant c. Now, some questions for practice. In first question, evaluate integration of 3x minus 1 upon x plus 2 whole square dx. For partial fraction, we will assume as 3x minus 1 upon x plus 2 whole square, a upon x plus 2 plus b upon x plus 2 whole square. In question number 2, 1 upon x power 4 minus 1, which you can factorize here. First factor x square minus 1 and second factor x square plus 1. And x square minus 1 again we can write as x minus 1 into x plus 1, and then third factor x square plus, which you can assume as a upon x minus 1 plus b upon x plus 1 plus cx plus d upon x square plus 1. In question number 3, 1 upon e power x minus 1. Here multiply in numerator and denominator by e power x. The numerator will get e power x and denominator e power x into e power x minus 1. Let e power x as d, and after that you can solve it.